Hello, in this video I want to show you a false proof, and I want you to see. I'm going to make certain steps. I'm going to try and have you find where the mistake in my proof is. At the end of the video I will tell you, but it would be nice after I go through the incorrect proof for you to pause the video and try and find out. Okay, so I have t is equal to a plus the square root of a squared plus b squared plus b over the square root of a squared plus b squared. Now, yes, you can combine these since they have common denominators, but I'm not going to. So we can write t squared as this squared, which would be a squared over a squared plus b squared plus b squared over a squared plus b squared, which would be equal to a squared plus b squared over a squared plus b squared, which is of course equal to 1. Okay? Simple. One solution like that. Now, we could also, before we square t, we could combine the a and the b, so we can get t is equal to a plus b over the square root of a squared plus b squared. And so now when you square everything, you are left with a plus b quantity squared, because that's what you do when you square it, over the square root of a squared plus b squared, and then squared, so those all cancel out. A plus b squared is a squared plus 2ab plus b squared over a squared plus b squared, which is not equal to 1. So you could see that in this numerator there's an extra 2ab, and that totally changes all of math. None of math makes sense anymore. Okay, so right now would be the time to pause the video and to try and find the error in this proof. Alright. Just getting a new marker. I normally keep it in my pocket, but whatever. Okay, so the error was actually this very first step. In this very first step, when I squared t, what I should have actually done was acted like this was the a term and this was the b term. So it would actually be a over the square root of a squared plus b squared plus b over the square root of a squared plus b squared. All of this should be quantity squared. Not just, you can't just square those individual parts. So you could work this out. I actually haven't worked it out. I'm going to assume it's equal to this. We can work it out right now. So it's going to be a squared plus 2ab plus b squared. So a squared is going to be a squared over a squared plus b squared. And then 2ab would be 2ab over the square root of a squared plus b squared plus b squared, which would be, this shouldn't have the square root underneath it. I'm going to get back to that, over b squared, and b squared is this right over here. Okay, so if I got rid of the square root here, then everything would make sense. So it's 2ab. Oh, because it's 2a times b, not 2a plus b. It's times in the middle. So it's the square root of a squared plus b squared times the square root of a squared plus b squared. So we can rewrite this and take away the square root sign, in which case you just get this, and you can rewrite that as a squared plus 2ab plus b squared over a squared plus b squared. So I guess now it all comes down to two different methods, both give you the same answer. Anyways, thank you for watching and goodbye.